So what's the purpose of all of this complete the square stuff? Well, it's nice because when we can't factor a problem, then we can use complete the square to find the two solutions. So if we were looking at a problem like this 9 probably would have started on the other side, but we can use complete the square if we use balancing equations in that balance line, and I drew mine in. So x squared can only be created by x times x, and this is a b value, so we would divide it by 2. So 8 divided by 2 is 4. And that c value that's missing is what we're going to add to both sides so that we can take a square root. So the c value is 4 squared, or 4 times 4, so 16. Remember, it's a balance line, so if I add something on the left, I also have to add it on the right. And 9 plus 16 is 25. And when I go now, I can take the square root on both sides and solve this problem by square roots instead of trying to solve it by factoring, because factoring doesn't work in this case. So we'll take the square root of both sides so that we can undo a quantity being squared, plus or minus the square root of that number. So we end up with x plus 4 is equal to plus and minus 5. So that x is equal to negative 4 plus and minus 5. So x is equal to negative 4 plus 5, negative 4 minus 5. So my correct answers would be positive 1 and negative 9. And those are my two solutions, which makes sense because I could have factored this problem, right? X squared plus 8x. And the 9 really would have been on the other side, right? Set it equal to 0. So minus 9 would be equal to 0. And that does in fact factor. X plus 9 times x minus 1. And this is going to be the big trick. When should you use complete the square, and when should you just use factoring? So for now, we're going to practice all of these problems with complete the square, and some of them will be easier to do by factoring. So my bell is about to ring, so I'm going to pause the video, and I'll come back and finish this one in a moment. Okay, so what does complete the square, and why do we do it, is the next piece. And so when we look at this problem, the first thing we want to do is we want to check to make sure that our leading coefficient is a 1. If it's not a 1, then we need to fix that by using division to get it to 1. The next thing we have to do is check the left side to see if we can easily factor it into a perfect square trinomial. If not, then if it's not already set up, if you can't do it, this is where the new step is. Isolate the x's. That means make it x squared plus your bx and leave a blank for c, because that's what we're going to have to introduce, is the c value. And put the constant that didn't work, put it over here. So put your c value, or really it's going to be the opposite of c, right? It's negative, because you're going to subtract it or add it to get it over to that other side. So in this problem, They've already done that first part for you. It was minus 21, so they added 21 to both sides. And now we need to complete the square, or create a perfect square. X times x, 6 divided by 2 would be a 3. Whatever we do on the left, we also have to do on the right. So, oops, that 3 squared is a 9. So I need to add 9 to both sides. So x minus 3 squared is equal to 30. And now I have something being squared, so I can take the square root of both sides. On the right-hand side, don't forget that means I need to consider both the positive and the negative of square root 30. So x minus 3, because square root undoes something squared, equals plus or minus it's 5.48. We don't want to know what x minus 3 is, we want to know what x is, so we add 3 to both sides. So our x is equal to 3 plus 5.48 is also equal to 3 minus 5.48. So my two possible solutions -1 and 52 cents, right? That should be right. So 848 and -152 as my two possible answers. Now I'm going to get you started on number 12, and then I'm going to leave you to finish it on your own. So we always start this problem with, can I create something squared? Is there a number times itself that's equal to -3/4? No. So we're going to go ahead and add it to the other side. X squared plus 7x, leave all the x's. You're going to add your 3/4. And now we can complete the square. We're going to have those blanks go right here. And we did have a leading 1, so we're all set. Now, x times x is x squared. It's a positive, and we're just going to do 7/2. Yeah, maybe I'm going to work through this whole thing. So to do 7/2 to square it, remember 7/2 times 7/2. So plus 49/4. So we're going to add 49/4. And we get positive 51/4. And we can take the square root of both sides so that we get x plus 7/2 equals plus and minus, don't know, the square root of 51/4, something over 2. Second, square root of 51 divided by 4, close parentheses, 3.57. Subtract, and 7/2, that's really 3.5, so 3.5. And maybe some of you had that decimal from the beginning. So that x is equal to -3.5 plus and minus 3.57. So my first solution, if I add, is going to be 7 cents, so 0.07. And if I subtract, I get -6, -7.07. So these are my two possible answers. would you please give number 13 a try? And 14 and 15 we'll do in class together. Actually, we'll check our work on 13 in class and do 13, 14, and 15 together. I need to get this uploaded.